In today's video, let us see how to express the given algebraic fraction in partial fraction. Let us first try to understand what partial fraction means. If you can recall, in lower classes, we have done sums like this, wherein we have individual fractions which we'll have to add or subtract and get the final answer as a single fraction. Wherever possible, we will try to factorize so that taking the LCM becomes easier. We will proceed, simplify the numerator and get a single fraction. Now, partial fraction is essentially the reverse of this. From the single final fraction, we are going to trace back and get what the individual fractions that make up the final fraction are. So, let us see how to do it. There are certain cases in partial fraction. We have to identify which of these the given question falls into and then proceed. And a very important criterion or prerequisite is that the degree of the numerator should be less than the denominator. That is, we can do partial fraction only for proper fractions. If it is improper, we will have to do polynomial long division and express it as a mixed form and then proceed with partial fraction for the proper fraction. Now, since there is one linear factor which is x minus 1 and one quadratic factor which is x squared plus 2, the case we have to take is, this is the question. Always the degree of the numerator must be 1 less than degree of the denominator. So, since x minus 1 degree is 1, linear, the constant should come at the top. Constant's degree is 0. For x squared plus 2, which is a quadratic, we need to have a linear factor. So, we proceed with this. This is the most important step here, because only if this is assumed correct, other things will fall in place. Now we have a fraction on the left, a fraction on the right. Since denominators are same, numerators will have to be the same. Taking LCM on the right, let us expand and group. We will group so that we have one x squared term, one x term and a constant term. So we have something on the left, something on the right. At this point, we can compare and equate the coefficients on both sides. So we will get a plus b to be minus 1, since that's the x squared, c minus b to be 2 and 2a minus c to be 8. Since we have 3 different variables and 3 equations, let us substitute for one in terms of the other so that we get 2 variables and we can solve the pair of simultaneous equations. So from this, a will be minus 1 minus b. So when we substitute for it here, 2 into a, instead of a, let us put this, we get minus 2 minus 2b minus c equal to 8. This makes, taking 2b the other side, 2b and c, we will get minus 10. So we have this as one, this as the other. Solving equation 1 and 2. C minus b equal to 2. C plus 2b equal to minus 10. Now subtract. minus 2b minus b, minus 3b equal to 12, implying b is a minus 4. A was minus 1 minus b, minus 1 plus 4, which is a 3. C minus b was 2. So C minus this is 2, which implies C equal to 2 minus 4, which is a minus 2. Now that we got all our values, A 3 by x minus 1, B is minus 4, C is minus 2. Since both are negative, we can put it here common, 4x plus 2 by x square plus 2. So hope that helped. I'll see you all in another video. Thank you.